One thing to think about is the sensitivity or elasticity. A good example of that recently comes from shipping. If you take the demand for shipping and the supply, they tend to be pretty inelastic. That is, most of my profits and my cost of production, shipping cost is a very small 1 or 2% of the total cost. So even if my shipping costs themselves double, then it's unlikely to have a big effect on my interest in purchasing the shipping. I won't shut down my business because something that makes up 1% of my cost has doubled in price. Same thing with demand. The demand for shipping and the supply, as a manufacturer, I'm the one who's demanding shipping. But if I'm a ship owner, then my supply is also pretty inelastic. There's not much else I could do with my ship, so when the price goes down, my options are pretty limited. What else could I do with it if I'm not shipping things with it? When the price goes up, what else can I do? I could order another ship, but it takes years to build. So when the price goes up, I can try to go faster and supply more shipping miles that way, but I can't go too much faster because of friction with the water and just the physics of ocean dynamics on a boat. So my supply curve ends up being very inelastic, as same with my demand. So when something changes just a little bit, let's say there's a global boom, just a small shift in the demand is going to have a big effect on the equilibrium price. Sadly, when things are bad, when the demand for shipping goes down, just a small drop could have a very big effect on the price. This is what we saw in the fall of 2008. The price was pretty high because of all the boom years, and then when suddenly people couldn't get credit, you couldn't get a line of credit because the financial crisis was going on in the fall of 2008, and the price of the Baltic Dry Goods Shipping Index, which is the global market price for shipping, like iron ore, for instance, that fell by, I think, over 90% in just a couple of months. So you see, supply and demand will move around. They respond to changes in income, changes in substitute good prices, or just changes in people's preferences. Right? Maybe the Surgeon General tells me that drinking beer is very healthy, so my demand for beer will increase. Maybe I find out that President Obama smokes cigarettes, so I decide, oh, maybe I want to smoke cigarettes, and the demand curve increases. Maybe I discover that I need to, there are fad and fashion kind of things. Hawaiian shirts might become very stylish, and therefore the demand, just because of fashion, will increase. When they're no longer fashionable, the demand drops. And you see trends in fad and fashion temporarily affecting the equilibrium price as the demand shoots out or falls back. So a number of things can change things. We tend to model it as a picture, but always keep in mind that supply and demand are very dynamic. Lastly, we've been graphing this, but let me tell you two other ways to think about equilibrium, because some of your professors think about it in different ways. You might present supply and demand in a table. I could have 1, 2, 3, 4, 5 like this. At a price of 0, people want a lot, and people don't want to supply very much. As the price goes up, I'm going to max this out. As the price goes up, people demand less, but as the price goes up, people supply more. And you can put everything in a table instead of in a graph, and then you can find the equilibrium price just by finding the spot where the quantity supplied is equal to the quantity demanded, and we know that the market clearing price for this product would be 5. You can also present the same information in equations and do it using algebra. we have a downward sloping demand curve and a upward sloping supply curve. Now you use your basic rules of algebra of substitution. I can substitute 10 plus 2p instead of the quantity because I'm looking for the price where these two quantities are the same. So you can find the equilibrium price with just a few steps of algebra and plug that price back into here. 10 plus 2 times 14 is going to be 38. You can check it here. 80 minus 3 times 14 is 80 minus 42, which is also 38. So at a price of 14, the quantity supplied and the quantity demanded will be equal. They'll be equal to 38. So this is another way to present and solve supply and demand equations for equilibrium or market clearing conditions. You can also use equations to solve for elasticities. If I take a demand equation and say when the price is 14, what is the price elasticity of demand? The percentage change in quantity is the change in quantity over the quantity. The percentage change in price is the change in price over the price. Now if these changes are large, then you might use average quantity or average price. You might use the initial quantity and the initial price just to sort of plug something into the denominator of that of this part or this part. What quantity is it? Some books will use average, some will say the original, and some will say, well, if you're just looking at a particular point rather than looking at a discrete change, looking at an infinitesimal change, you can just use Q. If you rearrange this, you have to check this. It's a quadruple decker. But what is the change in quantity with over the change in price? That's just that coefficient. Times price, which is 14. And what is the quantity when the price is 14? I think we said it was 38. 80 minus 42, yeah, it's 38. So that gives me 30, 42, 38. And now that you can calculate elasticities, you might want to meet my son Henry. Hi Henry, come on in. Say hi.
Hi.
Want to wave? Love you, buddy.